Okay, hello. I received a request to go over these problems with the transformations. So you got to do three things here. You've got to state the transformations in a proper order. You got to state the domain and range, and then you have to actually graph the transformed function. Yeah, so we can do that. That doesn't seem so hard. So for stating the transformations in a proper order, we said that it's just true 100% of the time that if you just went A, B, C, D in that order, you would be fine. But that's not my preference, so I'm not going to do it. So I like to kind of work from the inside out, but there is that rule that says you have to translate last. So working from the inside out means describing the effects of B first, then C, then I would go to A, and then I go to D. That's just the way I do it. Now, if you guys went A, B, C, D, 1, 2, 3, 4, that's not going to be wrong. So you can go ahead and do that if you want to. It's just not how I like to do it, so I'm not gonna. But let's get down to business. Looking at this, for this function, we can see that our A value is -2. We can see that our D value is 3. But for the B value, it's 1. That means it has no effect. I feel like that can't possibly be spelled right. Effect. Because if you dilate by a factor of 1, then it just doesn't change. And we can see that our C is 0, which means no effect. Because if you translate 0 units, then that has no effect. So obviously these we just don't have to address at all. So again, the A has two different effects, because if A is negative, that reflects, and when the absolute value of A is greater than 1 or less than 1, something else happens. We happen to have an absolute value greater than 1. So in my little order of operations, we would describe the effects of A first. And a bulleted list is great. Just if you guys do a bulleted list, that actually makes it easy for me to grade, so just do that. So state the transformations. We are going to be reflected over the x-axis. Then we're going to be vertically dilated. Remember, you can't just say dilated. You got to stipulate whether it's vertical or horizontal. So vertical dilation by a factor of, just say BAFO. And here is where you don't want the reciprocal. You'll say we're vertically dilated by a factor of 2. The A value is 2, give me 2. And then the last thing that happened is we were translated 3 units up. So in terms of describing the transformations, that I hope was pretty straightforward. In part B, we want to give the domain and range. Let's do that before actually graphing, although if we graph first, that would make finding the domain and range a little more straightforward, because you'd literally just read it off the graph. But let's not. So if my domain of the original function f is 1, 2, 3, 4, you know what? Hold on just 1 second. Okay. I made a new graph that actually has labeled axes, and I can also make it as big as I want in case our transformations don't fit. So we'll have that as an ace up our sleeves. So what's our domain? Now that I can read it off super simply, our domain is obviously -4 to 2. And guess what our domain will be after all these transformations? Well, all these transformations were vertical. Reflecting over the x-axis changes y's. Vertically dilating changes y's. And translating up changes y's. So the domain of f, the original function, is going to be the same as the domain of h. So I'll just go ahead and say, hey, this is the domain of h. I don't have to change anything, because none of my transformations were horizontal. So remember, that's a 4. That's a 4. Looks slightly more 4-ish. All right, now To come up with the range will be harder because the range of function f is -2 up to 4. But now we have all these transformations, but you know what? Just apply them one at a time and it's no big deal. We're going to get reflected over the x-axis, so that means the 4 that's a max becomes a -4 that's a min. The -2 that's a min becomes a +2 that's a max. Then we get, yeah, okay, I'm fine. In my head I was thinking of these as x values, but I don't think I said anything wrong. That's still true for the y values. We are now going to vertically dilate by a factor of 2, which just means these numbers double. So they go to -8 and they go to 6. Then you get translated 3 units up. That means you just add 3 to these numbers. So you go -5 and you go 9. So now this is the domain of H. Super psych. That's the range of H. Alright, so does that fit on my grid? I gotta go from -5 up to 9, so no, we don't have enough room up top. So let's throw this guy in the bin. Go get a new one that goes wide enough. -5 to 9. How do I get back? Okay, I'm back. So I apologize. I'm sure this is an example of one that isn't going to fit for you guys. Yeah, I mean, if I sync this up with what I gave you, then we can see apologies are in order, because you guys are going up. You guys go up to 8 and you needed to get to 9. So sorry, my bad. But now, I don't know, imagine a world where you had this grid instead, and everything will be a little bit easier. So we talked in class about how if you think you can just take these points one at a time and transform them in the coordinate plane, then be my guest. If there's only these 3 transformations, then you probably can. So reflecting over the x-axis means this doesn't move at all. Dilating it by a factor of 2 means it doesn't move at all. This point literally just goes up by 3. And that's true of any point on the x-axis. So maybe it wouldn't be a horrible idea to maybe transform these x-intercepts, just because it's so easy to do. We know that they are going to also just go up by 3. But the points we're interested in are really the vertices here, the bends. So where's this guy going to go? Well, he's going to reflect and go down to -4. Boink. Then he's going to get doubled and go way the heck down to -8, which is actually off the grid, so good to know that I should actually be giving you an even bigger grid, so that if you wanted to plot these things one at a time, the 4 would go to -4, then it would double down to -8, then it would translate up to the -5. It's going to finish its life here. Then the -2, what's happening to that guy? Well, the -2 reflects, goes to +2, then it doubles up to 4, then it gets translated up to 1, 2, 3, to 7. That don't feel right. I don't know. I'll trust it anyway for the moment. Alright, what happens to the 2? Mr. F's thinking he messed up. Reflect, dilate, 4, then go up by 3. Alright, something's wrong somewhere. Let me take this point, reflect it, it goes down to -2, it doubles to -4, it gets translated up to 1. I'm feeling pretty good that this is the right graph. So I think maybe I screwed up my range. We'll go and look in a second. I think this is happening, this is happening, this is happening. So why do I think I'm wrong? Well, because my range is only going from -5 to 7. So what did I screw? Oh, okay. Well, I should be doubling. I tripled. So that's weird and stupid. Hopefully you guys saw that happen and were screaming, you were yelling at the screen about how dumb I am. Okay, double this and double this. This is only 4. And then when you translate up, this is 7. Okay, please forgive me. That's our range. That's reflected in this graph. So everything's great here. I don't know. One thing to notice is, notice that that none of these points moved horizontally, like I was telling you, because we didn't have a relevant B or C value. There were no horizontal transformations. So that's what this one should look like, and that's 1 down, 9 to go, so I'm going to try to hurry up. Alright, so for number 2, this one's all horizontal transformations. Notice this is already factored out for you. So in terms of stating the transformations, there's only 2. We'll explain the 1/2 first. That's a horizontal dilation by a factor of. And don't say a half. With B, you want to give me the reciprocal. So we're being horizontally dilated by a factor of 2. And that's going to be, that's going to stretch us. Okay, so these are all going to double, which means 1, 2, 3, 4. That would double and end up here at -8. And then the -3, what's that want to do to us? That's a translation 3 units right. So I can see that that point is actually going to translate 3 to the right now and be here. So the good news is it fits on the grid so far. So what about this point though? If he gets doubled, he goes to 4, then he gets translated 1, 2, 3. That point fits too. So I think we're okay. I think this one's going to fit. Double it, it goes to 4. Translate it 1, 2, 3, it goes there. All right, what happens to this point? It's at -3. So double it, it goes to -6. But then you translate it back and it goes and it actually lands right where it began. Then what happens to this point? Double it, nothing happens. But add 3 to it and it goes . So I know I did this out of order, but I don't care. And you don't care either, I'm sure. But this should be the new version of this particular graph. This feels weird. Everything feels weird. Alright. Yeah, alright, whatever. I trust it. So you know what? Let's go ahead and just use the graph to answer part B. State the domain and range. Well, the domain is gonna... I wish I had my numbers on here. -5, 3, 6, 8. Okay, whatever. No, we don't go to 8. So -5 to 7 should be our domain. And our range, of course, didn't change from the original because all of our transformations were horizontal. So it's -2 up to 4. If you're curious, if you want to just make sure we did it right, then our original domain was -4 to 2. And if we apply these two transformations one at a time, then that doubling happens horizontally. So we go to -8, 4. Then that translation 3 to the right happens, and we go to -5. This is a 4, remember. 7. So yeah, we're good. If we apply the transformations one at a time, or if we, look at our graph, either way we can see our domain becoming what it becomes. Okay, moving on. So another one with just 2 transformations, but this time there is a reflection that will change our domain. Then there's a reflection and a dilation that will change our range. So we are going to see action in both directions. So let's describe them first. And I still like to work from the inside out. So this negative represents a reflection over the, geez, what could it be? Well, because it's on the inside, this transformation is happening before the function happens. That means it's happening to an x value. So if you change the sign of an x, let's see, it seems to go over the y. What if my original x was negative and I change its sign? Still seems to reflect over the y. This is clearly a reflection over the y axis. You don't have to memorize it if you understand it. If you understand it, you can just sketch it and figure it out. Then the next reflection happens. We get reflected over the x-axis. Hey, good news here. You actually don't even need to know which reflection is which because there's both and order doesn't matter. So let's say you made a mistake and described this negative as a reflection over x and this negative as a reflection over y. I would never be the wiser because it doesn't matter the order that you reflect anyway. So I don't even know which transformation you're ascribing to which negative sign. So that's liberating to hear, right? Hey, what's the effect of this 3? Vert, dil, bafo, 3. That's it. Those are the 3 transformations of H. Let's do that thing again where we sketch the graph first and then do the domain and range. Just cause. But let me cheat and make sure that I have a grid that actually fits. I feel like I know that we won't fit because if I try to triple 4, I'm going to end up at 12. And even with a reflection, we'll be down at negative 12. There's no room for it. So I'm going to go get a better grid that works just so that you guys can at least see what it should look like. Okay, I'm back. I'm going to take you on this trip with me because I just think this is kind of cool. So look, I set up a function down here called f. You don't need to understand why, but there it is. It's a piecewise function. It's all the pieces of our graph. Then I set up a function named h that is defined to be f with all the transformations, and I can actually slide these sliders now. So look, oh, the points don't move with it. Oh well, too bad. But you guys know the effect of a is that it vertically dilates us. You can actually see that happening. And you can see when a goes negative, right? When it goes to 0, we go flat. That's kind of interesting to see too. But the negative a's reflect us upside down. You can see that happening too. So if I return this to A1, we're back to normal. Ooh, it's so hard to do though. Just do this. You're a 1. Okay, what's the effect of the B? Go back to being a slider. The B should be our horizontal dilation, right? And values greater than 1 should actually squish, and it's working. You see that happening. Values less than 1 should actually stretch, but as soon as we go to 0, we'll just lie flat. Yeah, we just kind of die. And then the negatives are reflecting us over the y-axis and dilating. So again, you know this already, hopefully, but you know, good to see it actually happening dynamically. C should just translate us left to right. Kind of boring. Slide the slider and slide the graph. And D just slides us up and down. So up I go, down I go. But that's it. I show you this because I think some of you might care. Anyway, what are we about to do? We're working on the one that says negative 3 f of negative x. So okay, so that means my a wants to be negative 3. And my b wants to be negative 1, right? Alright, so I'm only bothering to do this because now I know exactly how big of a grid I need. Turn that off, turn the original back on. So I need that much. Yeah, okay, whatever. I won't make you suffer through that ever again. Line this up. I might need more as we're transforming, right? I don't care. Okay, does most go away? Okay, back to me in my little graph. Alright, so again, let's do this transformation. Oh, this is too much. Okay, what's happening to this point? Reflect. So it reflects over the y-axis and it goes to positive 4. Reflecting over the x-axis does nothing. And then vertically dilating it by a factor of 3 also does nothing, because 0 times 3 is still just 0. What about this next point? This guy, if I reflect it, it goes from negative 3 to positive 3. It's at 4, so if I reflect it again, it goes down to negative 4. Then the vertical dilation by a factor of 3 takes this point and drags it all the way down to negative 12. But that's it. Now, this point. It's at negative 2. Can't reflect over the y-axis, but I can reflect it over the x-axis. It goes to 2. Then I can triple its y value, and it hops up to 6. And finally, this guy. I'm going to reflect it over y, it goes to negative 2. Reflect it over x, it goes to negative 2. Triple its y value, it goes to negative 6. So that ought to do it. I can barely see this thing. So it's going to go up to there, down to here, back up to there. So that should be my transformed image. I'm fine with it. So B. It would appear that our domain is negative 2 to 4. It would appear that our range is negative 12 to 6. All right, and then pretending for a moment that we don't trust our graph, we would grab the original domain, which is negative 4 to 2. And the only transformation affecting our domain is the reflection over the y-axis, which should turn us into a negative 2, positive 4. And then, yep, that jibes. What's our range? Negative 2 to 4. And this time we have two transformations, so make sure the reflection happens first, and you turn into negative 4, positive 2. Then make sure that the dilation, actually no, I lied. So those don't care what order happens. You could reflect and then dilate, or dilate then reflect. So if we dilate, we're going to go to negative 12, 6. And that also agrees with our graph. So I'm feeling pretty good that both my domain and range are fine. Feeling good that my graph is fine. Feeling not so good that I let this get cut off. That's on me. My bad. I'm doing a bad job. Okay, moving on. It's 10:30. I'm going to just put out this video with just the first 3, I think, and I'll put out a video of the rest. I mean, you guys should be going to bed. This is way too late. So I'm going to stop here. I'll put out a video for the other ones later.